watching. This is my newest live stream. I'm continuing my generative art project. I'll start out by recapping what that is and what I want to do. So, first things first, I have this style of art. That picture's not very clear. We'll see if there's a clearer one. Maybe this one. Nice. So, I have this style of art that I made in, I think I was in 5th grade, and I think it's cool. I think other people usually think it's cool, but that doesn't really matter. This is what it looks like. The first one I ever made, I started out, just making these. So, okay, I guess I'll explain it this way. There are a few rules that govern this, which is just you draw curved figures. Everything's a curve. That makes it look cool. And everything has either two sides, two curves, like this. This shape right here has two curves. I'll zoom in. So like this is a two curve shape. There's this outer curve and then this inner curve, and it's filled in. This one has two curves. This one has three curves. So it has to either have two curves or three curves. It touches here, but they shouldn't touch. There should be white space between, and ideally the amount of white space is about the same everywhere. And then you get these cool kind of geometric patterns that look like they fit in. I showed this last time, but I'll show it again. I have a video on my YouTube of me doing one of these drawings. Oh, there's my live stream. So if we go over, so this video here. So you can see that it starts out, you just draw the initial one. This is a time lapse, so it's obviously really quick. But you start out just drawing one of these shapes. Let's see if I can catch when there's just one on the page. There we go. So that's the first one. I started out with the three-sided shape. Filled it in, and then so that's the first step, and then from there it's draw an adjacent shape, fill it in. So there I drew two adjacent shapes, and now I'm drawing another adjacent shape, a fourth one that's outside of one of the secondary shapes I drew, and from there it just kind of proceeds until you have something that looks really cool. So this isn't very complicated, and I love making these sorts of drawings. But I don't often, because you sit down and then it's an hour of just coloring in, blank stuff with marker, which I guess could be kind of therapeutic, but it always feels a little bit like a waste of time. And I've always had it in my head that this could be automated. I didn't know anything about computers when I started doing this style of thing, so I didn't even know it was possible. But basically, since I started doing computer coding in 2017, this idea has been in my head. So that's what I'm trying to do with this project. So the first step I would want to do is just draw a single one of these figures, and draw a single one of the simplest version of these figures, which would be a two-sided one. Here the first one I drew is three-sided, but I would like to draw a two-sided one, like this, or this, or this, or this, or this, because two sides is simpler. So then it comes down to, and again, lots of this was discussed on the last stream, so sorry if this is a recap for you, but I think it's important to outline where I'm at. So, so I'm trying to draw a single one of these elements, this element, that element, or the other element. I have some code that does that. And this this code is where I left off last time. Last time I got this code that automatically on the last live stream, I was able to automatically generate some shapes, and I felt like, okay, I'm satisfied with that, and so I stopped the live stream. But the shapes are not perfect. They do not end up looking like these, and I realized that there are some kind of constraints that I put on these shapes that I'm not really aware of. They're like aesthetic constraints, but it kind of constrains the curve. Like one thing is, for instance, I favor sharp points, and I'm always trying to make a sharp point, not a dull point. Like the angle should be really small of the point. If I think that angles, like this is kind of a wider angle, but this is a wide angle that's about 90 degrees, but I really think that that doesn't look very good. I think though that the shapes that give this drawing its interesting feature are the ones like this, where it really hooks around and you get a sharp point on the end, or this or that, or this one. So I think that yeah, I need to put some additional constraints on these curves that I'm drawing, but I don't know what those are. So that's what I'm going to attempt to do today, is fix up the curves. Actually, maybe... Oh. I was wondering if I could change the name of this broadcast. Well, I don't know how to change the name. I wish I had named it something else. Oh well. So, okay, so desktop, personal stuff, projects. Generative art. Okay. Right, and I think it's initial curve dot pi is what I have, even though it's not the initial curve, it's supposed to be the whole initial shape. So pi initial curve dot pi. Well, that one was pretty good. So you can see kind of where I'm trying to go here. That's not a perfect shape, but you see how that kind of looks like a two-sided shape, one of these two-sided shapes. It's a little bit different though. Like for instance, I was talking about the sharpness of the corner or the edge, but this one's probably too sharp. Like none of these have such a thin line going down like that. So maybe you want some extra space in here, could be a rule. Something like that. And like I said, this is a pretty good curve. You could see if I try to do some different curves, there's some not so good ones. And this is just randomly generating curves. And that again was a pretty good one. That looks like the Nike swoosh. You get a lot of those. Okay, and so real quick, how am I generating these curves? These are quadratic Bezier curves, like this one here, which matches with a parabola. That one does, not all of them do. Okay, cool, and here's how it looks. So you have an endpoint, you have two endpoints, and then a control point that's somewhere else. And then you draw the line by moving proportionally, some proportion along this line, and moving the same proportion along that line, and then those give you, some new points, and then the new points give you your green line, and then, wait, how do you, no, I'm having trouble thinking, how does this work? It's the point that intersects with the line. interpolated linearly between Q0 and Q1. Interpolated linearly. I don't know what that means. Interpolated linearly. How do you get point B? So point B at time equals 0 is at P0. Time equals 0, P0, Q0, and B are all in the same place. Q1 and P1 are all in the same place. Oh, interpolated linearly. So I guess then these all are stepped along some proportion, and then this is also the B is also the same proportion between Q0 and Q1. So when the proportion is all the way up to 1, then B will be at Q1, and when the proportion is like at 50%, then it should be right in between them, and then when the proportion is at 0%, it should be here. And you can see here, right when t equals 0.5, boom, right at 50%, right at halfway on the green line. Watch again, 0.5, halfway on the green line. One more time, 0.5, boom, halfway on the green line. Okay, so that's how a quadratic Bezier curve is drawn. And the code that I have generates this quadratic Bezier curve. Okay, so that's nice. Okay, so the code that I have generates random points. It puts random points on the canvas. Here it was this point and that point. And then it picks another random point as the control point, which is P1. So it puts P1, it puts P0 and P2 here and here onto the point, and then it chooses some random control point, and then it draws the first curve, and then it chooses. So actually, I'll just write this out in Notepad. So first thing it does is generate two random endpoints, and since I'm just trying to make the first shape, they can be totally random because we don't have since it's the first shape, we don't have to worry about this shape colliding with any other shapes right now. So the first thing I do is generate two random endpoints, then generate random control point for curve 1, and then I draw curve 1, and then generate random control point for curve 2, and then create, and then draw curve 2 using control point from 4 and the endpoints from curve 1, and it draws that second curve. So pretty far it's giving me some nice curves. Let's see if it can give us a bad curve, because not all the curves are good. Last time I got some curves like that and was satisfied. Oh good, here's a bad one. So here, actually this would look good if it was just this part, but you see there's this little overlap here which is awkward. So that's the first thing I want to prevent. Things to fix. So I want to fix the overlap. Don't want any overlap there. Let's see if we could get anything else, any other weird curves. There's the overlap again. us no overlaps, and then suddenly 2 overlaps. 2 overlapping shapes. There's another overlapping. So really that's kind of the big thing, is the overlapping. Selecting the second control point so that there isn't an overlap. Oh, and also this problem of the points don't quite meet up. Overlap between curves and endpoints not quite matching up. Let's see if there's anything else. I think there were some like ugly curves, like the man keeps doing that. I think there was a curve that was something like, okay, so this kinda shows it. There's an overlap, but also this is really thin, so might want to do something. About how thin it is. Not about how thin it is, about preventing the shape from becoming too thin. Okay. Let's see if we can get some more curves. That one was pretty good. Oh good, this kind of shows it. So, you saw there, it started the first line about here, drew that over here, and then met with this line and went basically straight away over here. So I don't know, that's kind of hard to see what I'm talking about. So I will, oops, that's not what I wanted. Alright, so the curve started down here, went up like that, so that's the first curve, and then the second curve, it went back to here, and it started the second curve, drawing in basically the opposite direction, like that. That's a really shaky version of it, but the end result is that there's this smooth corner instead of a sharp corner. You can see, don't need it that big. I wish I could draw a line in here. So this would be like the end points, or actually this is one obvious endpoint. Other endpoint is like around here somewhere. And so we're going to draw a line between those two guys. Not a bad line. Okay, so if we draw a line between those two endpoints, and then look at the way that this curve goes. Remember how these quadratic Beziers are formed right here. So wherever this point is, the control point is out here behind it, pulling it towards that point. You can imagine it as it's pulling it. And so when we see that I don't know what to call it, the edge of the curve, the tip of the curve, the nook of the curve, the elbow of the curve, the big elbow of this curve is out over here, which means that the control point, I don't really know, but let's just say it's here, somewhere out in here, in this space over here. line between these two endpoints, I think you then make another perpendicular line. So if, say, we had this first one, now we want to make another line that is perpendicular to the red line. And then another line that's parallel to that. And then say that the control point for the second curve has to be somewhere in here. And that's the other thing, is last time I was trying to draw a convex shape, so we could say that if this is let me think, convex versus concave, I never remember which is which. I think, yeah, I don't remember. Okay, so if we're making a concave shape, in the drawing, if we look at two-sided shapes, a concave two-sided shape would be one like this. That's what I'm calling a concave shape, where it's kind of inwards. I guess there's kind of a big, with these two-sided shapes, there's a one line is usually bigger, and so the smaller of the two lines, if that one is concave, then I'm calling the shape concave. Whereas here, this would be a convex two-sided shape, this one right here. And the thing is, even with the convex, it comes down to a point. It shouldn't ever be rounded. Like with these convex, I mean, it's kind of hard to make a point, because I was using markers here, but, you know, it still comes to a point. There's a point right here. That's a point. It's definitely not rounded. So, yeah, that's what I want to fix right now. So I have some new code that I wrote. I'm gonna pull that up. I forget what it was. I think it's Pat Bez. Okay, so endpoint, control point, quadratic points. Oh yes. So I did, this wasn't on a live stream, I just did this on my own. So, I guess what I did here is this draws one Bezier curve. I set up a bounding box. I think this code is bad. It didn't work. I'm just gonna start new, with a new file. Okay, first, actually, I'm going to walk through what I'm going to do in that file. So, we could go into Microsoft Paint. Oops. And put in some 2D shapes. So, the first thing I want to do is generate a couple of points. I guess it could be orange. new steps because it's steps for the new code that I'm building. So, just a sec, I'm aligning my windows. Okay, so, new steps. Needs to fix new steps. So the first thing is generate 2 random endpoints. Doesn't matter where they are, they can be anywhere. Now, the next thing we want to do is calculate equation of line between 2 endpoints. That should be easy. So now making that line. Okay. Now calculate curve 1 bounding box. Calculate curve 1 control point bounding box. And so that's calculating the bounding box for the first control point. So there's going to be some rules for the bounding box. We're going to have to play around with what the values are, but this is a good general approximation. So the bounding box for the first curve is going to be in red. No, oops. What is this? Okay, whatever, I'll just draw a new one. Okay, so now this is all going to be spitballing. Approximately good. Now, dab in the middle. But if you can just imagine that the green line is smack dab in the middle, then the red generates the bounding box for the first control point. Now generate control point for curve 1 somewhere in bounding box. Now there's a new point, so say the point gets generated over here. That's in thickness. And this one's going to be blue. So this is that control point. Okay, now draw curve 1. Yeah, okay. Draw curve 1. Okay, I think, I'm not sure if this is the case, but I think that if I generate a bounding box for curve 2, using point from curve 1 as corner. So what if the point is in the middle of the box? So I think now I have to draw a new box, except the corners of the box look like this. Oh, not too many colors left. Okay. Okay, so yeah, I think that should work. Generate the first bounding box, generate point within the first bounding box, then generate second bounding box, generate point within second bounding box. Oh, so I'll add the new point, which say is over here. can guesstimate it. Okay, well, I'm gonna ponder that question while I go to the bathroom and I'll be back. So, um, need to calculate when curve becomes vertical. So, calculate control 1 curve point, control 1 point bounding box. Okay, so, use line between control points with, say, 30% of ends chopped off. Okay. Now, use line between control points with 30% of the ends chopped off. And then Pi, what's the first thing we want to do? If I go look at this other file, well, I could just go into my initial curve file and see how I draw that. And I'll make this new file similar to this one. So, import turtle stuff, math, don't need, Bezier, don't need, because I can make my own. Debugger, don't need, great. Okay, now this is just going to be a script that does this. And then I can organize it into classes and stuff later. So the first thing I want to do is generate random control points. I do that somewhere here. I just have to go in here and make sure that I remember how to do it. Okay, import numpy as np, np.random dot np.random. np.random dot random. I remember rand int. So this is random between 0 and 1. For I in range 100. Print np dot random dot random. Yeah, so that just gives a value between 0 and 1. Cool. So let's say size scale equals 25, so that the biggest size is 25. Okay. And now, oh, but we want negative points too. So, we could print this. We could print whatever that value is, minus 0.5, and then the highest number will be 0.5, the lowest number will be minus 0.5, and then what, multiply by 2? Cool. So I'll just copy that. Oops. Can't copy that. Oh. I can only So I do want to import numpy x, y. So first we go to x equals that of 0, y equals that of 1, put down, and then basically the same thing as this, except it's going to be endpoint 2 instead of endpoint 1. And now if we run that, it should draw just our center line for us. Pi single shape.pi. What the heck? Oh. Times. Okay. What happened? Okay. So that I think keeps the screen up. I'm not that familiar with Turtle. Okay, run it again. Whoa. Those were random points that were very close. They're all around the same area. Maybe 25 is too small of a scale. 250. I don't know what is happening. So here I do pick up, then go 2 points, and put down, and then go to these different points. So put down. That seems like it should work. Okay, so now I can try endpoint 1 is equal to 0, 0. And then endpoint 2 is equal to, say, 10, 10. And let's see what it does. Hey, that works. Maybe this I need to put inside. Instead of outside. Oops. Did I take away the 2? Didn't mean to do that. Okay, so put that back there. Paste it in here. And so paste it in here. Get rid of it here. Okay. This canvas. Change the sky size scale back to 25 because 10, 10 looked good. Now running the file again. plus 50. Okay. That worked pretty well. Okay, now size scale should be bigger. See how 25 looks. That looks pretty cool. No problems if you're in it. I think 50 should be fine. Nice. And I'm gonna make it 40 just so there's no curves that could be out of bounds. So that looks really good. Generating two random endpoints. Drawing a line between them. So that, okay. Okay, next thing to figure out, what I think I'm going to try to do is recreate this without the dots. Hey! The dots are growling at each other. Bad. Okay. Python turtle draw dot at a point. Wonder if this is possible. red bounding box, but I don't actually want to generate this red bounding box. I want to get the point that is inside 30% back from the edge. So how do I do that? I have to think. Point back from the edge. Okay, so I draw the two sides. Then draw a bounding box for the first point. So okay, so how about the first thing is we find the distance. Find distance between points. And we get point 1 and point 2. So if we want to find the distance between 2 points, we can say the value we want to return is 0.1. So the x value of 0.1, which is just the first index, minus the x value of 0.2, also the first index of that point. Take the value of that, square it. Yeah. And then you take, pretty sure this is it. Take that whole thing, add to it the same thing, but the y's, differences between the y's squared. So y minus y, yeah, because it's just the triangle, the Pythagorean theorem. So if you get the y distance, that's one leg of the triangle, square that, get the x distance, that's another leg of the triangle, square that. Now you have the Pythagorean theorems, a squared plus b squared equals c squared. So now you have, with the two legs of the triangle, so now you squared them, you have a squared plus b squared, so it's c squared, so now you just have to take the square root of that, which is to the 0.5. So, not y, 1. Cool, so that's find distance between points. So, having trouble thinking. So, toward the other point. How do we tell what direction we're going in? How to get the new point? want to go to the previous point, but we want to stop before we get there. Oh, well, we might be able to do it. Let's see which direction our turtle is facing. I'm gonna make it go slow so that I could see. What's happening. Okay, so then I could do turtle dot left 180 to tell it to make a 180-degree turn. Now let's see if it does it. This is hard to do math visually. I guess I could try to do it in Paint. Okay, so we get the first point. Second point, then if you're sitting here, you're naturally pointed horizontally over there. Now you say, what is the x and y of the first point? So it's all just a trick. I'm just having trouble thinking of it. So you say sine theta, oops, sorry for that noise. Sine theta, that should be a distance between those. So if that distance, call it d. So then we can say d times sine theta is equal to y, and we also have that d times cos theta is equal to x. Okay, so think, what if we had this where we had point 1 here and point 2 over here. Then what is the procedure? Say that this is at, so get the difference 0.1x minus 0.2x, and then you also get 0.1x minus 0.2x there because it's negative. So basically the absolute value of 0.1x. Man, that's hard to think about what to do. Do you do the absolute value of it? 0.1, the absolute value of the difference between the x's? absolute value of difference in x's. This is getting angle. So you get the absolute values and the difference in the x's. Then if you do smaller y minus a bigger y, then it will be up there. But if you do bigger y minus a smaller y, then it will be positive. So it should be the negative of the difference in the y's. Oh man, this is confusing. How to get the angle? So yeah, just say, I think I could do it this way. So, don't want to go left 180. What we want to do is make point 1 0 0. So if you turn point 1 into 0 0, let's see, P1 is equal to P1 of 1 minus P1 of 1. But if P1 was negative 10, oh yeah, negative 10 minus negative 10. So you just do P1 minus P1. So you do P2 minus P1. Yeah. Point. So we could say shifted 2 is equal to 0.2 there are 2 points. First point is 0.2 of 0 minus 0.1 of 0, and the second one is that except with the y values. Okay, so that's our shifted 2. End point, not point. Okay, now shifted 1 is just 0 0. Now to get the angle associated with an x and a y, theta is equal to shifted point is bigger than 0, then the angle we can do cos of theta. Man, what does that tell us? If the x value is positive, then we can say that cosine of theta, cos of theta is equal to x, and we also know that so sine of theta, so if theta is negative 45, sine of negative 45 is minus root 2 over 2. So sine this is saying if we're in the first quadrant, what is the rule? Cos of theta is equal to x, and also sine of theta is equal to y. So that should be pretty easy. Python inverse sine. Inverse of sine. Okay. Okay, so I'm going to import arcsine and arccos from math, and then see if it's in degrees or radians. Arcsine, oh, okay, of 1. So it is in radians. Sine 0. Sine of minus 1. Okay. So this is saying if we're in the fourth quadrant, I think we could say the same thing. Okay. Theta would be the inner angle. So, if the inner angle, oops. Okay, so that's theta. This is the inner angle. And then it goes up to this point, and then we want it to turn around. Well, we know that theta plus 90 plus that equals 180, so that plus that. So that angle is equal to minus theta. So that angle is 90 minus theta. Let's draw I'm gonna redraw this part down here. So we have the big line going through. We have our dot right there. This is the dotted line right here. Okay, so that means that this angle we said is 90 minus theta. Okay. Now, okay, so the problem I was having in Turtle is it turns straight back like that. So it gets to here, but in Turtle, the point is facing over here, and so I can do a full turnaround. That is 180 degrees. But I can't just do a full turnaround. I need to do a full turnaround. Well, gosh. It depends what quadrant you're in. See, because you could calculate, so you could calculate the initial angle no matter what. So, if I can calculate the initial angle, that should be all I need, actually. I'll just do this. So, if it's in the first quadrant, that's what to do. Else, if, well, yeah, not else if, just else. Oops, wrong place. If x is less than 0, theta, so if x is less than 0, so if x is greater than 0 to this, small. So say the value is, I mean, what if you do arc cos of -1 from math import arc cos? What? Oh, not arc cos but a cos. So a cos of -1. So if x is less than, yeah, then theta equals a cos of shifted 2 of 0, so the x value, oh, that's not so bad. It's just been so long since I did any trigonometry. It's hard to think about, which I took for granted when I was used to thinking about it. So now we have theta. And what do we do? Okay, so we want to do turtle dot left, turtle dot pick up, turtle dot go to, turtle dot put down, turtle dot left, and we want to go left theta, and we always go left, and then you end up back at the end. Okay, so it draws the second point, then it goes left, so then it turns 180, so now it should be back at the line, then it goes forward 10, but after it turns, we want to change the color. Where did I put that? Oh yeah, turtle.pen color. Make it blue, say. Just to make sure that we're drawing back over the line. And yeah, let's see what happens. Hopefully this works. Okay. Well, that's interesting. We'll try again to try to watch what happens, because I think it should turn theta before it does anything. Yeah, no matter what, it just turns to the opposite side. That's weird. So why doesn't it do this initial? Did I not save this? But, yeah. Huh. Turtle dot left. Theta. So that's not gonna do it. Okay, well, I'm gonna end this live stream with the goal of get chart / image created in Paint 3D to automatically this, but